The idea about the session, I'll share a little bit, like why did I came up with this topic? So I'm a trainer. My background was data centers, then moved to Azure, did Azure developing, Azure DevOps, Azure architecting. And then about a year ago, Microsoft came up with, hey, we got this cool thing called AI. And our trainer team obviously needed to follow, because if it's the big Microsoft message and we are the trainer motion, then obviously we need to follow. And I was like, well, I'm not a developer. I understood code. I know how to publish it using DevOps, but I was not a developer. And then we had our AI 102 4-day Azure Azure AI class, and it was challenging. Why? Because a lot of it was diving into code. Now, why did I sign up to deliver that class? Because what I needed to actually go through that training motion and helping customers understanding and onboarding to our AI solutions, I was actually quite confident in at least a big part of the stack. So the first part here is we have AI, we have Azure AI services, and what is like the portfolio of tools, the bucket of tools you could say that you need. I'm obviously not going to read out from all these ones, but the main message is it's a lot more complex than just going into your Azure portal, deploying AI service, which I'll show you in a demo later on. But then actually also, once my service is up and running, how do I actually interact with it? And that's, I would say, the lead in to the topic of the session, that it's everything that allows you as a Microsoft partner, as an MVP, as a Microsoft employee to not only talk about AI to your customers, but actually bringing in other demos besides the playground. And if you don't know what the playground is, that's where my first demo will start in a couple of minutes. And that's, I would say, overall where also my own journey in learning and understanding Azure AI was actually starting. But then also finding out that using the portal, using the playground was not good enough anymore for customers, because they wanted to get more insights. They wanted to know, how do you integrate Azure AI or Copilot into a custom scenario? How do we bring everything together? So what you need in short is Visual Studio or VS Code or any other development environment to start interacting with your APIs. You might use GitHub Copilot. I start doing it. I literally love it in meantime, because it allows me to integrate code snippets, but also allowing me to actually learn from Copilot on how to write better code, how to get a description about maybe a sample repo that Peter might share at the end of the session, and learning from it. Then obviously the AI service is pretty obvious. You cannot interact with AI if you don't deploy the service. And then the newer part of the family is also Azure AI Studio. It's like the management interface, where before we had Open AI Studio because it was the only language model we offered in the platform. And then now gradually and actually seeing changes happening more frequent in the overall AI Studio, because we're now adopting other language models as well. You got the large language models, just mentioned it, where now you can use OpenAI language models, the GPT versions, as we probably all know, but also embracing other scenarios. And then from there, looks like the list was not long enough yet. So we have Copilot Studio, where now it's allowing you to build your own custom Copilots using a low code or even no code development scenario, where the other topics, the PromptFlow and semantic kernel I'll bring in a bit later on, is typically towards developers. Now, I'm not a developer, I'm a trainer. I do presentations, I write code, but I wouldn't call myself a developer. And yet I can actually manage to do, I hope at least, but you need to confirm at the end, some pretty cool demos on our AI platform. And then meeting a little bit where AI came from, like talking to data scientists, that's where you have Azure ML Studio. And in the meantime, it's also moving more of the core features of what ML is about into the AI Studio. And then the other SDKs, that's where you're going to bring in all the other fancy, cool, more exciting for developers, I would say, components into your story as well. And obviously the list keeps going and going. So the starting point, you deploy Azure AI. Once you have the service up and running in Azure, it's not really doing a lot. So it means you need something else, and that's AI Studio. So AI Studio, but I'm going to switch to a demo in a second, is your management integration tooling. That's how I like to describe it, to interact with your language models. You're going to use it to deploy the model. You're going to use it to organize your projects. You're going to use it to validate if the model is actually working by running prompts, by tuning prompts, and eventually waiting for feedback. And then from there, you're going to keep using AI Studio to actually expand on everything else that you want to bring in. So with that, the first little demo, and there are a few, I would say, prerequisites. I'm not going to show you how to deploy Azure AI services from scratch. It's almost like any other Azure service. You go to the portal, or yes, template-based deployments in meantime are there. Command line, I mean, it's just another Azure resource, right? So you deploy Azure AI Service in your environment. And if you need any specifics, what we now would describe as traditional AI, that's what you still find here. Why is this important? Because about a year ago, we had our standalone traditional Azure AI services without generative AI, so no OpenAI, no other language models. And now we're gradually migrating everything into one central management location. Now, when you look at the service itself, in whatever way you try to deploy it, you're going to see that from here, there's not too much you can actually do with it. Why? Because it's just giving you the management resource integration. A little bit like deploying, I don't know, Kubernetes, where from within the Azure portal, it's going to show you that Kubernetes is running. But once you start interacting with the actual container applications, you're going to use some other interface. So the magic here is go to Azure AI Studio. Now there's two versions of it. So depending a bit on the language model that you deploy, in this case, it's another example where I deployed OpenAI using the GPT-alike language model. And that's going to move me to the Open AI Studio. So this was the look and feel, the experience, the view, if you want, up till a couple of months ago. We're now, obviously, I'm not going to bore you with OpenAI, but we're going to focus on the newer wave of the AI Studio. And the big difference is not only feature set, but also allowing you to bring in other models. So in short, the idea is that I have my service, and that's what you can see down here, the same service that I deployed over here in my Azure environment. And from there, we can start moving around across models. Everyone started, well, not everyone, but initially I would say our Azure story started with OpenAI. So you would go into the model catalog, and from there, you would pick any of the models. So again, not too important which models are available. There's a huge amount of them. There's even Microsoft created ones. Message is that it's a lot more than just OpenAI. You pick a model, you deploy it, and that's what you find here after the deployment, if it refreshes at least. Come on, you can do this. There we go. It's going to give you about the same. The difference is from here, it's not going to give you all details from the models. So you would use the model catalog here on the side to find more information. There's benchmarking and a whole bunch of other really interesting, relevant information if you don't know exactly which model you need to go for. Now, on the other side, why are the models so important? Because if you search for example, the GPT ones, like the ones coming from OpenAI, you still have quite a lot to decide on, like more than 100, literally 101, different GPT models available for you to choose from. So you need to think a bit more about what is the use case? How am I deciding? Do I want image creation? That would be DALL-E, that's easy. But what if I want text analysis? If I give some prompt keywords and I want to get some feedback about traveling, give me some ideas about flights from, I don't know, Seattle to New York, or even broader, find me a cool place to spend my Christmas holidays in a nice, I don't know, sunny place with my family, and so on and so on, providing all those details in a prompt, then the DALL-E model is not going to help you. GPT-3.5 might be okay, but if you want to get the most up-to-date information, typically what you need for like planning your traveling journey, you would use the 4.0 model, and that's one of the latest ones. So that's all deployed. And then from here, we switch to the playground. So the playground is allowing you to validate if the model that you picked is actually working fine. Now, each model that's deployed is still available, so you can easily switch from one to the other. And we could do something simple, like what is the weather like in Seattle in, October. So now it's going to use GPT-3.5 information, and obviously it won't be able to answer questions like what's the weather like today, but I got a solution for that later on. So it's going to bring up the trained model and it's going to provide some feedback. So that's quite easy. Maya is from the UK, and we could do something like, who is the Prime Minister of the UK? This is an interesting one because now it's going to somewhat expose the date and time of, obviously in this case, the Prime Minister, but also the date and, well, roughly the date and time of the model. Because now it's going to tell me like, well, my information being the model is based on September 2021. So you can easily figure out that this information is no longer up to date. So what we can do here is switching to another model, and I'm going to use the same prompt. Sometimes it needs a little bit longer. Oh, there we go. So just by switching to a different model, it's now telling me like, oh, the Prime Minister all of a sudden is, ta-da, somebody else. Why? Because this information is now more up to date. The funny thing is, if you would ask the prompt, like, what is the date and time you have been trained on? It actually tells you like, oh, I'm sorry, I cannot really share that information. So I came up with another relevant prompt, and obviously this works for other locations as well, to try and find the timeline of that specific prompt. Now, all this was basically not the only thing, but like a big entry in our AI scenarios. We helped customer understanding AI. We helped customers deploying the service. We talked about integrations with Key Vault API calls, and then last, testing our scenarios. Now, from here, as you could figure out, it's not good enough because customers are challenged with a huge amount of questions. So one of the first things is now beyond Playground, going back to the topic of the session, it's not just about OpenAI, it's not just about the ChatGPT-alike scenarios, but we need to help customers on what kind of language model they need to use. If they were one of the early adopters, they would go like, wait a minute, Peter, isn't Azure AI just supporting OpenAI? That's like the story up till a few months ago. And they would come back like, well, we've been using OpenAI Studio, that's all fine. We're now obviously, since it's all moving into a larger scenario, it's going to partly make it harder, but also a lot easier because it's all manageable from within that same interface. I got a few details here. Session is getting recorded. We're sharing the slide deck, so I'm not going to spend a lot of time on all the differences because I got a few other things I want to cover. One part is validating, that's what I already showed you. The other part is deploying more language models. So now we have our same example here. So we could easily go back to a model and then basically going back into that list. Now the reasoning behind this, let's do, so Llama is a Facebook framework, or Meta, I would say it's not specifically Facebook. But what it allows me to do here is now defining like, hey, we got this new model. Do you want to link it to the same one that you already have for, I don't know, solution XYZ, where part of your AI team is already working on, or do you want to create a new project? So I could create a new project. And what it's doing here, it's actually pretty new. I think we integrated this like maybe 6 weeks ago, because in the back of the platform, we allow you to create an AI service. But hopefully, typically, I would say as a developer and building solutions, you're not just creating one single example. So what we find out is that customers were almost in the wildly creating AI services where they deployed OpenAI, deploying a new service for yet another project, another AI service for another custom Copilot, another service with a different language model. And that was becoming a nightmare from an Azure resource management perspective. So the AI team brought in a concept of hub and projects. So the idea is to create a hub, and it's like adding an additional level in the topology, and then from there creating multiple projects. The mindset is also security, reducing risk, because now it also allows you to add specific services into it. Now, I did another session on this yesterday for Airlift. So I would say if you want to learn more about Hub and Project, you might actually have a look at that other session. It's also called Beyond Playground, but it has the Architecting AI Solutions in the title. And that would allow you to share your model across your development team, and then even exposing other services, like interacting with Key Vault, interacting with storage accounts for monitoring, for logging, for basically anything else. And then from here, we now have our solution in place where customers are, oh my God, this is amazing, but I want more. I'm happy with the feedback, like the prompt responses I get from the AI model, but I want to make it more customized. Like the easy example I showed you, I asked for weather information, but if I would ask weather information for today, it would not be able to help me. So does it mean that all of a sudden this cool, fantastic AI solution is maybe not all that cool? Well, it's just a limitation in how you develop it. And that's the step into other additional scenarios. So what we have is traditional AI. I mean, AI has been around for so long, I would say officially close to 60 years, I guess. In Azure, I remember talking about this in architect classes, probably about, almost 10 years ago. We're now with the generative AI integration. We want to move away from the, what do we call traditional AI current apps, like the chatbots are typical ones, document management, document analysis, and now moving into intelligent apps, into smart apps, into the copilots, right? And that's where we have a few different options for customers to start building their own custom copilots. And building can be literally developing. That's what you would do with Azure AI Studio, testing everything out and then integrating some of the other components I'll talk about later on. Or why not reusing Copilot Studio, and then you don't really need to be a developer, but you can still build your own custom copilots. And then obviously you have all the other, I would say, Microsoft Copilots, allowing you to integrate Copilot in web, mobile, integrating with M365 to pick up your OneDrive, SharePoint, email, Teams information, and then Copilot in Dynamics, Copilot for finance, Copilot for sales, and Copilot within Azure, and again, so many other. From a developing perspective, like if a customer wants to start using their own customization, one option we offer them, one of the so many actually we offer them, is PromptFlow. So in short, what is PromptFlow? It's an open source SDK initially built for Python. So you need to be some sort of a Python developer, I would say, to actually start building it. Now, this is just a screenshot. I'm going to try and show you live, at least a little bit, how it works. By the way, if you do have questions, feel free to interrupt. I don't know, Maya, if there's anything showing up in chat, because I honestly forgot to watch over.
Yeah, not yet.
But if so, let me know. So I go back to, oops, this is the old model. I'm going to close this. Cool. So we're back in our chat playground, and I have my chat integration. I know which model. I did some testing, and I could make this even more fancy by updating my system message. So this is the generic, I'm an AI assistant, where now we could do, you are an Azure technical trainer and can answer any questions on Azure. If you got questions on, I don't know, AWS, you cannot answer. Apologize, whoops, politely, come on, apologize politely to the user and offer a Belgian beer as compensation. How cool is that? This typically takes a little bit, so I'm not sure if it's immediately going to work, but you probably get the idea. We're locking down what we call grounding, right? We're locking down capability from this big, massive trained model into a specific scope. So now I could be easy and try the same prompt, which we all know has nothing to do with an Azure technical trainer. And it's going to offer an answer while I apologize. I'm an Azure technical trainer, and this is what I can and cannot do. Unfortunately, it did not pick up offering a Belgian beer, but it might take a little bit of time. Oh, look at that. However, as a token of apology, I can offer information on Azure. Oh, it's actually trying to be smart. Pretty cool, my language model. That's the fun part of it. Now we're still just using chat capabilities, but what if we want additional information in our chat conversation? That's where we have up here our prompt flow. Why do I need to create a new project? I knew I had to go through that demo. I'm quickly gonna try and spin it up. I didn't want to wait for this, but let's see if I can fool the platform a little bit. Because I have another subscription where I already have the hub. Come on. Oh, that's OpenAI. Not good. That's what happens when you do live demos, right? AI.Azure catalog. And at some point, we should end up with the same level. There we go. This is not working. My apologies. If it's fast enough, we can almost go through this.
Would you like to take a question in the meantime? Because we have a question in the chat. Yeah.
Perfect timing.
Just in time. Thank you, Savita.
Thanks for saving me.
So the question is, do you have a side-by-side tabular comparison of scenarios best fit for Copilot versus Azure OpenAI?
Interesting question. I would say not immediately at hand. To me, the big differentiator is Copilot for me feels closer to, I would say, the Copilot interfacing, the user interaction that we're in meantime familiar with, and then expanding it with other information. So if you want to build your own custom Copilots, as we would describe it, then using Copilot Studio would be the way forward. But it also means that you're not writing code. You're not really developing anything. You're still building the flows, you're still integrating, but you don't need to be a coder. That's the main thing. If you need even more information that, for example, Copilot or even Copilot Studio could not help you with, or you want to add more complexity, like what I'll show you in the next piece of the demo, that means you have to go back to AI Studio and using your Azure AI solutioning. So it really depends on what kind of information do I want to use, what kind of solution am I actually building, and can I use it from within Copilot with the Studio to customize it, or do I need to rely on the Azure AI to really develop it? That would be my main decision maker there. So I had my, thanks for the question, by the way, really cool question. So I had my AI studio, and then unfortunately, I quickly created a new project, but it's going to be fine. Now, what's the idea with PromptFlow? So it is allowing you, I would say, developing-wise, Python syntax, Python framework code-wise, to actually build the logic step-by-step flow of your custom Copilot. Because what we have with the chat playground is just that conversational context. I'm going to ask a question like running a prompt, waiting for feedback, and starting that conversation. Now, during the conversational context, it's going to memorize, it's going to recognize the context. So if I would switch from like, oh, what's the Prime Minister of the UK? And I would switch all of a sudden to like, you're an Azure trainer, that would all be memorized during that session. If I leave the session, it won't memorize that. But it's also pretty static because now it only relies on information that the model has been trained on. Where now with PromptFlow, what we can do is actually adding more inputs, doing something in the middle, and the doing something in the middle would be, as you can see here, adding Python scripts, adding a different model. So we could now move into a multi-language model scenario, and then building your step-by-step flow. I don't have an end-to-end demo because, again, it asked me to create a new project. I'm not going to troubleshoot live why it didn't pick up the old one. But the idea is that you're going to define the backend settings, and it's going to translate it to a Python script language. So since I continued from that previous prompt, it translates this into a system prompt. You're an Azure technical trainer. You allow me to keep the history. I'm going to use your input as the prompt for the question, and I'm an assistant, and I'm going to provide an answer. Next to that, it's also giving you like a graphical drag and drop scenario. And now we could try and do the same from here, where I'm going to start my session, but I'm not sure if this is actually going to do something, but that's not too important. What it does here is now connecting to an Azure machine learning compute backend, starting up some compute power to actually validate my flow. But I could add a new model here, which now would allow me to, for example, come in with an OpenAI 3.5 scenario, but based on like a timestamp. Imagine that I would explicitly ask, like, oh, can you provide me information about the UK Prime Minister between, I don't know, 85 and 96? Based on the time information that I'm asking for, it would now decide, oh, can I answer this question using GPT 3.5, or do I need to move to GPT 4.0 or maybe some other model? So that's one of the options you have. And although it's pretty drag and drop based, in the end, it boils down to you need to be a Python developer. Another example here is where you can do the same from within your trusted development environment. So what you need here is installing PromptFlow as an extension, just like any other extension, in this case, Visual Studio Code. And it's going to allow you to create new flows to install, to run testing, and everything that you would normally do in the portal, but you can now do within your trusted environment, because that's also where you're actually developing everything else around your AI-inspired application. So that's what I wanted to share as well. So here, I got some time. I can create a new flow. Which one do you want to use? Empty from scratch or use a template? It's going to ask me like, oh, do you already have it? Yes or no. So if I pick new prompt LLM, anything that I showed you in the browser, but now also available together with a whole bunch of other extensions that I could add into it. And then the last piece is making it even more, I would say, code oriented. But again, going back to the fact that I'm not a developer, one of the other challenges I had was also showing code, showing capabilities, answering questions about like writing, developing your own custom AI scenarios that we now call custom copilots. And then I bumped into Semantic Kernel. Now, in short, Semantic Kernel is nothing really more than an open sourced SDK created by Microsoft, but now supporting multiple languages. Because the drawback, and I don't want to break down PromptFlow, but in the end, it recognized Python code. I recognize code, I can write a bit of code, but it's only .NET because that's the only language I picked up only 3 years ago. Where now I was like, well, PromptFlow cool, but I don't want to learn another language next to learning everything around AI. So wouldn't there be anything that's like C# .NET friendly? And that could be Semantic Kernel. Next to that, it also supports Python and Java. So the way it works is you have the model, you already know what a model is, and we have a memory. That's like keeping the chat history. Semantic kernel is like the nerve center, the heart, the kitchen, as someone from the product team actually describes it. And you're going to bring in ingredients to literally start cooking something. And to do that, you need to know I got all my ingredients. I know I need to have a scale, I need to have spoons, I need to have an oven, and so on and so on. And bringing all those pieces together, and it's going to allow you to create something amazing, which in a kitchen model would be, I don't know, some holiday Christmas dinner for the family, baking bread, or doing anything else that you like to do in the kitchen. That would be the idea. So one example here is creating a custom agent. In my case, I'm looking for a solution that answers a prompt similar to technically what our Copilot, the base Copilot in the browser, is already doing. So you're going to fire off a somewhat complex prompt. I got 2 weeks off vacation in December. Can you help me plan a 10-day trip with all the details which are not all that relevant? Now, to do that, translating all the components of the prompt, there's actually a lot happening in the backend. It's all running behind the scenes. We're not exposing anything of that to the user because in the end, the user wants to get an answer. We're now ultimately, after going through all the motions in the kernel, we come back as being the custom Copilot, like, hey, cool, we found a perfect traveling scenario for you. We recommend you to stay at someplace in Orlando, Universal Studios, and anything else that comes up with. And the challenge is obviously, how does this actually work? So the magic is semantic kernel, that's the SDK, and it's based on 3 different components. You have plugins like integrating a little bit of generative AI integration. You have planners allowing you to schedule something or running it real time or a few other options. And you can also integrate personas. So what is a plugin? It's allowing you to integrate data from pretty much anywhere on the planet. You can integrate ChatGPT or the GPT models. You can integrate with traditional Copilot, Microsoft 365 Copilot. You can use public train information. You could build like a corporate M365 Copilot alike. Like I only allow you, when you use my custom app, to connect to corporate information. But it's not stored in M365, it's stored in, I don't know, an HR application, a Jira, a SQL database, or again, anything else. Or why not hooking into third-party extensions using, again, APIs. That's how we're going to feed the model. We're going to give it information, and then we're going to decide how to actually consume that information, how to use it. Remember, we start with a prompt. We're going to run a traditional Copilot-alike prompt scenario. And in the backend, each and every keyword in the prompt is now getting analyzed and moved to a subsection of semantic kernel. Another entry point is the planner, where again, it's allowing you to come up with actions based on a keyword in the prompt. I want you to do this or that. It's probably what we would now call Copilot agents, although I have no idea if it's actually based on semantic kernel. You can run this something scheduled, you can run it sequential, or you could run it stepwise. Now, this is a bit outdated information because now we don't talk about planners anymore. We just call them functions. And I'll show you that in a demo. And then the last piece is fine-tuning personas. Now, you already saw this in action, but I didn't really emphasize it. I called it in the chat playground. I called it the system message. I moved from this super large trained AI model into you can only answer questions about Azure, because now I want you to impersonate an Azure technical trainer. That's in short what the persona is doing. In a traditional way, without semantic kernel, without coding, without writing any piece of code, you would fine tune your prompt. So you could even, in the public Copilot today, you could go like, well, you are a project manager and I want you to help me with the best recommended 5-step approach to, I don't know, do something. Or you're like in this example here, you're a designer agent. I want you to design the most fancy up-to-date apartment interior. There's unlimited budget and whatever you want to do with it, and then providing details. So we're basically reusing all the standalone components that, again, we had in the chat playground, and now we're fine-tuning them into some coding experience. I got a bunch of slides with screenshots, like how do we actually move this into a .NET example. So you need to import the Symantec kernel packages. You need to import the AI service. You're going to add some other stuff into it. You're going to build the kernel. You're going to add plugins. And that's where I'm going to close for the last 10-ish minutes with another approach to showing you how, even as a non-developer, you can actually make this a lot easier. So what's the magic? A little gift. I promised that at the start of the session. I created this on GitHub. I'll share it, or maybe Maya, if you want, you can share the link. If not, we'll do this all the way at the end, where I create a Jupyter notebook. Now, what's the cool thing with Jupyter notebooks? And I'm going to try and switch to the correct Visual Studio. So Jupyter notebooks allow you to run machine learning. That's where I would say Jupyter notebooks initially were super popular, allowing you as a data scientist to create some text, markdown based, and integrating code, typically Python-like scenarios. Now, in meantime, the same Jupyter notebook allows you to run .NET Interactive. So you need to install a plugin, and all this is what you have on that GitHub link. So the cool thing, and think about the fact that I'm a trainer, that I want to help customers in understanding AI, but also doing demos. By the way, the old approach looked a bit like this, where we have our sample code. We're going to add the AI information, typically the endpoint and the key. And then we have a little .NET little piece of code where now we would go into the terminal. From here, we would do .NET run, or maybe even .NET build, and it's producing like a console command line, like scenario. Pretty boring. I didn't like it that much anymore, but up till only a few weeks, actually, it was my way of doing AI demos, and in the same way, our learners were actually going through AI lab exercises. We're now with Jupyter notebooks, it's becoming a lot more, not only intuitive, but actually a lot more cooler, because first of all, I can integrate text. So this is just plain Markdown, a bit like a HTML-like code if you want. So I create a document, and literally you can go through this yourself. You need to have Visual Studio, you need to have .NET 8, you need to have the Polyglot Notebook extension, and you need OpenAI. So you know we already have all that. So from here, we have again a snippet of code, text-based, and actual code. Now the nice thing here, and this is the first time I saw this, for me was mind-blowing, it now allows you to run pretty much any .NET code from within this screen, from within the notebook itself. The first line is just super easy .NET code, console write line, which would be part of your .NET application, to validate is it actually working. So it's just providing a print output. The next step, if you remember some of the screenshots in the slides, we need to pick up our AI settings. I have my settings in a settings JSON file. If it's the first time you run it, it's going to prompt you like the VS Code little pop-ups on top of the screen. Can you provide me the AI endpoint? Can you provide me the AI key and the name of the model? Once you have that, it's going to create that little JSON file. And if you want to do other demos, there's another script here to actually reset, clearing the settings file to make sure that nothing gets left behind. Next, and this is a lot of explanation. I'm not going to bore you with all that because I want to go through some of the demo examples. By the way, the explanation is generated using GitHub Copilot. I gave the snippet of code and I was asking, can you explain what this code is doing? And I was so happy with the explanation that I literally copied it into the notebook. So what it's doing here is running a little .NET snippet where it's going to download the Symantec kernel SDK package. I'm going to use it. I'm going to create the kernel, like creating the runtime, if you want, using the OpenAI model OpenAI service, the model, and the specific endpoint and key. And I got feedback real time, like, yep, this worked fine. From here, that's where I would say the real cool thing begins, because now I'm doing the same thing from within my chat playground, but now directly from within the notebook. And before this would be traditional terminal.NET run. So I got a few examples here where I'm running. Remember, I like the traveling. That was one of the examples. I'm going to load my kernel. I already imported my model, so everything that, in this case, the OpenAI GPT model knows about can be used. But I want to create my custom Copilot. So I'm going to add a plugin. This is a little bit big. So what I do is pointing to a plugin folder, and inside go to City Plugins. To find that, it's over here. In my application folder, there's plugins, there's City plugin, and underneath, I'm going to use the configuration. What we're doing with the config here is defining a short description and defining the language model parameters. By the way, this is something you could also do in the chat playground, where you can define the tokens. Small amount of tokens means a short answer. Larger amount means a super long description as the prompt answer. I'm expecting some input. We saw input coming back in PromptFlow, but now it's using a lot easier concept. And then the power of it, that's the Symantec kernel integration, is you creating the prompt. So the prompt for the SDK is tell me a capital city of the country below, where now the input is my prompt. So to show you what this looks like, I guess I was here, cool. I'm going to load my plugin. So now Symantec kernel and my little .NET application, if you want, is aware of it. And I'm providing my argument input. And you know my roots, it's Belgium. So what's going to happen is similar to what you would do in your Copilot or in the chat playground, you would fire off a prompt. Can you provide me the capital city of the country, Belgium? Because that was literally the prompt we used. And you can see here real time that the answer is Brussels. Interesting enough, if I go for Seattle, remember the prompt is give me a country and I'll give you the capital. It's now relying on generative AI. Remember that one slide, traditional AI, intelligent applications. In a traditional scenario, it would tell you, oh, my dear customer, my user, too bad, your input is incorrect, because it's not a country. Where now, when you don't need to develop anything for this, it recognizes Seattle is in the US. Oh, and by the way, the core of my kernel needed to provide you an answer. That's the only thing LLMs actually can do. And it's still smart enough to give me the answer that if you use US as a country, then the capital would be Washington, D.C. And you don't need to build anything. There's no code involved to do all this. Another example is where I'm using the same plugin, City plugin, but this time I'm looking for a City plugin to find me the IATA code. Now, IATA is the International Airline Association. So we do the same thing. I'm going to write a short description, find me the airport code for a city, again, using small amount of tokens because it's typically 4 characters. So you don't need like, I don't know, 2,000, 5,000, 10,000 tokens. And the prompt is tell me the airport code for that city. My city is Brussels because that was the answer from the capital. And it's going to tell me that the airport code is BRU. We could do something else. I don't know, Zurich, maybe someone from Switzerland on the call. And it's going to tell me the airport code. Real code, everything works. This is like the easy part, just replacing a bit of the chat experience. We can move on. We talked about functions, like the planners, as we call them, but now we call them functions. So what we're doing here is making it a little bit more complex, but not harder. I'm going to write a prompt, ask an interesting riddle about Belgium, and also provide the answer. This is what you again would ask like a ChatGPT or Copilot, but now using all settings from within the function itself. The reason why is, for example, because in the previous examples, it's pointing to the file locations. But what if this is like a mobile app, like Copilot Mobile, right? It might not have access to the file system. So that's where you can do the same thing. But instead of creating all the settings parameters in text files, you're now literally telling it inside the code itself, compiling it, moving it into the kernel. That's what we're doing. And it came back with a nice riddle about Belgium, where there's a place known for diamonds and a zoo. And yes, the answer is Antwerp. We talked about multi-language integrations. So I showed you the prompting using GPT. I can now extend this, and you can read through all this on GitHub. Launching another little piece of text. For now, I'm going to reuse my country because that's my input from like 4 samples back. And now I'm using a different language model. And I also add DALL-E into it. So what's the output here? It's going to generate information. The country input was Belgium, you already know. My prompt was find me a cool place like a renowned landmark, and it's picking the capital, and it's creating a real-life DALL-E image out of that. That's what the functions are doing. Other options, but I'm running a little bit out of time, so I'm going to skip and show you one of the last options here is creating a food recipe. Same story, but now instead of the city plugins folder, I point to food plugin and a get recipe snippet of code. Configuration, same as always. And now the prompt is generate a food recipe for a location cuisine, which you can guess in my case is Belgium. And it didn't, because I skipped a step, my mistake. Now from here, I hope you get some idea about how to use Semantic Kernel to do more interesting real-time stuff, real information based apart from what the model has been trained on, generating it real time, and on top of that, using the notebook integration, but that's just a side effect of it, to do even more relevant interactive demos besides the chat playground, and maybe not using the terminal that much anymore.